Ram Ram, hello all. My name is Shivam, and today I am going to discuss a very important topic which is called probability. Okay, so probability and statistics are related in a very important way. They are kind of they share a very kind like a kind of very important relation between them. So probability allow you to evaluate the reliability of your conclusion about the population when you have only sample information. Okay, so this particular thing, this particular thing is very important. Now you can relate this thing with the inferential statistics. So in case of inferential statistics, we learn that in inferential statistics, what we are trying to do, we are trying to make some conclusion, we are trying to make some, like we make some discussion on the sample data, and then we are trying to increase the same thing, we are trying, and then we just use the sample information, we because we have just a sample information, and based on that sample information, we are trying to make some conclusion, we are trying to make like some inference about the population. Okay, so this is what the meaning of inferential statistics. And now as I told you that to understand the inferential statistics, or to like evaluate the inferential statistics. Okay, so definitely this is a very hypothetical thing, this is a very like a hypothetical thing, that we are trying to make some conclusion on the whole population based on just a sample information. So we need to have something, we need to have some kind of a tool which can measure our conclusion, which can evaluate our conclusion, that whether this conclusion or whether the inference which we are trying to make, whether this conclusion or this thing is correct or not. Okay, so probability can be used as a kind of a tool which can give us this evaluation. Okay, now to understand the probability, to understand the probability in a much better way, definitely we need to at least understand these two terms first. First one is called an experiment. So experiment is nothing but a process by which an observation is observed. Okay, so like you are tossing a coin. Okay, so what kind of an experiment you are doing, what kind of like an observation, what kind of a like a measurement. So we need to do like experiment to get to get like probability of any particular event, and that is the second important term, that is the event. So event is nothing but a outcome of it is an outcome that is observed on a single repetition of experiment. So experiment, so you can do experiment in a repetition. Okay, so in a repetition you can do an experiment. So that sample event is nothing but it is the outcome that is observed on a sample repetition of an experiment. Okay, so this is like a probability. So you can consider like two cases. So when you have a sample coin, when you have suppose you can consider two situations, that there might be a scenario where you have you need to toss a coin. So when you have when you toss a single coin, so you can see it can give you either head or tail. Now if you toss the coin repeatedly and you generate a hypothetically a large number of heads and tails, when you generate the entire population, so in that scenario what happens after generating entire population, when you ask someone that okay fine, I'm again going to toss a coin, and now tell me the probability, that what may be the probability that I'm going to get head this time. So I think everyone is going to give the same answer, that is 1/2. But here we are having a population. Okay, so we are having a whole population. So in case of a population, probability helps you to get the likelihood of any event. And in the second scenario, maybe where you toss a coin just for 10 times, and you are not able to generate a 50-50 result, you are able to generate maybe all the 10 times you get 10 maybe a head, or maybe you get 9 times head. Okay, so it may possible that your coin is biased. Definitely your coin is biased if you get a 10 head. This is very this is we are not able, probably we are not able to say that the coin is fair if it generate 10 heads in a row. Okay. Here we have just 10 data, we just have 10 experiments with us, so we need to we just have a sample information, and here we can generate we need to use a probability. So here probability helps you to evaluate your like conclusion, whether the conclusion which you are making for the population data whether it is correct or not. Okay, so fine, this is like event and an this is like a probability which we can understand with this example. Now we can understand the probability with a term which is called a relative frequency. Okay, so there is one important term, there is like one term which is called a relative frequency. Now with the help of relative frequency also we are able to understand the exact definition of a probability. Okay, so here I'm going to give you the exact definition of the probability. Okay, so relative frequency. Now what is relative frequency? So an experiment can be anything. So suppose I'm trying to take a grade of maybe some students. Okay, so maybe I'm trying to just take the grade of maybe few students. So suppose first student get maybe a plus, then I'm having a, then I'm having b plus, then I'm having b plus again, then I'm having b, then I'm having c. So 1 2 3 4 5 6, and then I suppose I'm having d. So I'm having this 7 observation over here. Now if I try to note the frequency of each, so the frequency of a plus is 1, frequency of a is 1, frequency of b plus is 2, frequency of b is 1, then c is 1, then d is 1. Okay, so this is we call a frequency. Now if I talk about the relative frequency, so what it be? So 1 plus 1 plus 2 plus 1 plus 1 plus 1. And now if I so relative frequency is total number of like a total number of frequencies. So we need to add all these numbers, and then we are going to divide all these numbers by the total number of total number of observations. So we have 7 observation over here. So if we do this thing, so we are getting 1. So relative frequency is 1. Now if someone asks you, or if someone asks you that what is the total probability, so total relative frequency is always 1, and even the total probability is also always equals to 1. Okay, so if so now can we say that this total relative frequency is equal to total probability? So can we say in terms of a concept also that both are having the same idea, both are having the same concept? No, not at all. Okay, so definitely there is kind of a similarity, and that is why I just use this relative frequency to make you like understand about the probability. So there is a kind of a similarity, but they are not exact similar. Okay, now uh, suppose if I I can give you this explanation with the help of this example. So suppose if I ask you the question that if I toss a coin, okay, so let me tell the probability. Okay, so what is the probability that if I toss a coin, if I toss a coin, then toss a coin, then I'm getting, I will get, or I'm getting head. Okay, so if I what is the probability of getting head? So this might be a question. Now I can take 3 things over here. So maybe this is the experiment. Okay, so experiment, then event, like that outcome, and then maybe here is a relative frequency. Okay, so maybe if I toss a coin for the first time and I'm getting a tail over here. So what so relative frequency is what? It becomes 0 by 1. Now if I again toss a coin, I'm again getting tail, so it is 0 by 2. Then 3, maybe I'm getting head over here, so it is 1 by 3. Then maybe 4th time I'm again getting head, so it is 0 by 4, sorry, 1 by 4. Then maybe I toss a coin for 10 times. Okay, and if I toss a coin for the 10 times, and maybe last time I get head, and in between all the time I'm getting just tail. Okay, So what is the relative frequency? So relative frequency is 2 by 10. Okay, so relative frequency is 2 by 10. Okay, so now relative frequency is the formula for relative frequency is nothing but it will be a frequency divided by n. Okay, so okay, so but if I ask you what is the probability that if I toss a coin then I'm getting a head, so you everyone is having a same answer, everyone can give the same answer, that is 1 by 2. This is what we have learned in our childhood. Okay, so but relative frequency changes. Okay, so with each event, with each experiment, relative frequency is changing. Okay, so this is what happened in case of relative frequency. Now if I toss a coin, if hypothetically if I toss a coin maybe for 1 crore time, okay, that is a huge number, that is, yeah, so if I toss a coin maybe 1 crore of time, so definitely after tossing a coin for 1 crore time you are getting this number. So 49 crore 83 lakh and maybe some 976. Okay, so uh, so 3 4 5 6 7, so 49 crore 83 lakh 97,600. Okay, so this might be you can say, okay, so I think this should be this. Okay, so 1 2 3 4 5 6 7 2. So if I toss a coin maybe for 1 crore times, so maybe this is I am getting over here. Okay, now this will be 0.4983, which is very much close to the 0.5, which is 1 by 2. Okay, now if I toss a coin for one more time, okay, suppose if I toss a coin maybe for one more time, even if I toss a coin maybe for 10 times, okay, so can you get some fluctuation over here? Okay, definitely not. Okay, so even if I toss a coin maybe 10 times or maybe 20 times, and maybe after tossing a coin for the 20 time I'm getting just maybe a 5 head, then also I'm not getting a lot of fluctuation over here. Okay, this value can be fluctuate only maybe from 0.495 something to 0.501. Okay, this much fluctuation is possible, but this value is not going to fluctuate very large. Okay, so this is not going to like it is not going to give up on 0.5. Okay, so this is like this is the actual definition of probability in terms of a machine learning, in terms of a like data science. So what is the meaning of a probability? So probability stands for, so probability is nothing but a limiting case of relative frequency when our population data reach when our experiment reaches to a population, when our like experiment reaches to a infinite numbers. Okay, so that is what a meaning of a probability. So probability, if I write down the definition of probability, so if I suppose take an idea from here and if I try to write down the definition of a probability, so probability is nothing, probability is nothing but it is the probability is the limiting case of relative frequency. So limiting case of relative frequency when the size of sample approaches size of the population. Okay, so now this is called a probability. So now this is how we can write down the probability. So it is nothing but when size tends to infinity, and the formula is frequency upon n. So this should be a frequency upon n. Okay, so this is what we call a probability. Okay, so probability is nothing but a limiting case of relative frequency when size of the population sample approaches to the size of the population, or when size of the sample reaches to the population. Okay, now if I talk about, okay, so in case of a probability itself, in case of a probability itself, there are two kind of a thing. Okay, so there are two kind of a cases, like where independent independent thing, independent event or dependent event. Okay, so independent or dependent event. So now there are two kind of you can say events. Even the dependent event can also be it is called a conditional probability. Okay, so independent event means what? When like two events A and B are said to be independent if the like any event. Okay, so maybe there are like two events, so event A and B are considered to be independent if there is like no impact of event A on event B and vice versa. Okay, so there is like the probability of maybe any event, probability of maybe event B is not influenced or changed by the probability of by the occurrence of event A or vice versa. Okay, so this is called an independent independent event. Okay, you can simply understand this thing. You can simply understand the independent event. So tossing a coin is also an example of independent event, because you are not suppose if there are okay, so maybe event A is getting a head, and then maybe event B is getting a tail. So these both the events are not going to influence by one another. Okay, so maybe for the first time if I toss a coin I can get a head, or maybe second time if I toss a coin again I can get an head. So the second time when we are trying to do that experiment, so it not depends on that what we get on the first time tossing. Okay, so independent events are totally there is no kind of a dependency. Okay, you can take an example that throwing a dice. Okay, so if I ask you that suppose if I throw a dice, then what is the probability of getting 5? So the probability of getting 5 is 1/6. If I ask you that what is the probability of getting 3, so the probability of getting 3 is again 1/6. Okay, so both the event of so suppose event A is probability of getting 3 and event B is probability of getting 5. Both the events are not going to influence by each other. Okay, so this is what we call a independent and dependent event. Okay, so now sorry, independent event. Now if I talk about a dependent event, so dependent event can be easily explained or understand by the by the definition of a conditional probability. Okay, so suppose I am having this chart with me. I'm having this chart with me, and maybe there are like some male, then females, and and then I'm having data of veg and non-veg. Okay, so vegetarian and non-vegetarian. So maybe I'm having this kind of a data with me. Okay, now if I ask you one question, if I ask you a question over here that what is the probability, what is the probability that if female is selected at random, so from here, from this data, if a female is selected at random, then that female will be a vegetarian. Okay, so now I think the question is very easy to understand, that what is the probability that if I select a female, so out of this whole number, so I'm having a data of maybe a 28 people. So out of this 28 people, if I select a female, okay, so I have in female category I have eight female. So if I select one female at random, then what is the probability that that particular female is a vegetarian? Okay, now I think everyone is able to understand this, and anyone can give the answer, because anyone can simply understand that that particular value is nothing but it is going to be a 5/8, because there are total 8 females are there. So I'm going to select from 8 females. And how many females are vegetarian? So like I think 5 females are vegetarian. So this is going to be your answer. Okay, so 5/8 is going to be your answer. Now if I write this 5/8, so this 5/8 can be written in this way. So 5/28 divided by 8/28. Okay, so probability of a female. Okay, so this is what, this is nothing but a probability of like a female. So probability of I select like a female, and that female is a vegetarian also. Okay, and this is a what, this is a probability of female simply. Okay, so this is going to be my answer. F intersection V divided by FP of F. Okay, so this intersection means when there is a like similarity. Okay, so this the 5/28 means what, the selected person is female also, and that selected person is vegetarian also. Okay, and this is the whole thing is denoted in this way. Okay, so this whole thing is denoted in this way. So this way, F/V. Okay, now this is like this is what we call a conditional probability. Okay, so so here in conditional probability, what you are doing, you are trying to find out the probability that the selected person is vegetarian given on a condition. Okay, so this is why, that is why it is called dependent event. Okay, because it depend on one like a previous condition. Okay, so probability that the selected person is a vegetarian given that that selected person is female. Okay, so this is what we call a conditional probability. So if I write in a general form, so the general form, the definition can be written in this way, that conditional probability is what, probability of occurrence of one event, probability of occurrence of one event, occurrence of some event. So probability of occurrence of some event on a condition, on a condition, on a condition that another event has already occurred. Another event has already occurred. Okay, so probability of occurrence of some event on a condition that another event has already occurred. Okay, so this is what we call a conditional probability. Okay, so I think yeah, this is all about probability and a conditional probability, and this is it. Now in the next session, I will come up with a probability distribution. That is again a very important topic, and that is again a kind that is again trying to build a relation in between. With that also, we are trying to evaluate the things which we are getting from the inferential statistics. Okay, so thank you so much, guys. Okay, so if you have any query, so just write down your query in a comment box, and thanks a lot. Okay, ram ram, bye bye.